All right, hello chemistry students. We're going to do some examples here to help you out with the shape worksheet number 1. So what we're looking at here is we have these different compounds. We're going to draw the electron dot structure, the structural formula, name the shape that it makes, the bond angle, and then declare whether it's polar or nonpolar. So the first one here, we've got CHCl3. So the first thing we have to do is look these up on the periodic table. You're going to need your periodic table, either your hard copy from the yellow packet or the one that you get online. Either one, you can use your periodic table. But we've got, for this one, we have carbon. You just need to locate these. Carbon is in group number 14. We know that everything in group 14 has 4 valence electrons. Remember that. We have hydrogen is right here. That's group number 1. Everything in group number 1 has 1 valence electron. And then the last one was chlorine is in group number 17. And that everything in group number 17 has 7 valence electrons. So we will draw these out, at least one of each one of them, just to show where they are or what they look like. So carbon, group number 14, 4 valence electrons, remember 1 on each side before they start to double up. Hydrogen was in group 1, that has 1 valence electron. And then chlorine was group 17, 1, 2, 3, 4, 5, 6, 7. This is important that we draw these out because we need to find out which one of these 3 different atoms goes at the center of this electron dot structure. If you remember from the rules, the one with the most single dots goes at the center. Not the one with the most dots altogether, because chlorine has 7 dots, but chlorine only has 1 single dot. Whereas carbon has 1, 2, 3, 4 single dots, and hydrogen also only has 1 single dot. So carbon is going to be the one that goes at the center of our electron dot structure because it has the most single dots. Group 14 with 4 single dots, whatever the element is always going to be at the center because that's the most that it can have is 4. Then we can put our other elements here. Let's put chlorine, and each chlorine has 7, so we'll put 1 right there, 2, 3, 4, 5, 6, and 7. That's one of the chlorines, and remember there's 3 chlorines. That subscript right there tells you how many that you have. There's another chlorine, 1, 2, 3, 4, 5, 6, 7. Here's another chlorine, 1, 2, 3, 4, 5, 6, and 7. That accounts for the 3 chlorines, and now we have 1 hydrogen. And the hydrogen, right here, hydrogen with its 1 valence electron. Okay, and that's what it would look like. I just put the different colors for the different atoms and their valence electrons so you can see where they're coming from. Okay, the structural formula for this, we're going to have carbon at the middle, and each one of these lines represents a covalent bond. Okay, where the electrons are being shared together. So there's a covalent bond where carbon is sharing 1 electron with chlorine, and it has its 7 valence electrons. There's another covalent bond right here with chlorine, and its 7 valence electrons. And the hydrogen only has 1 electron that's being shared with carbon, and then the last chlorine with its 7 valence electrons. Right there, 6 plus the one that's being shared with carbon. Okay. Anything with a group number 14 at the central atom is a tetrahedron. Okay, kind of a hard one to spell. Tetrahedron, what that looks like. Okay, and if you remember off the sheet that we did from our notes, the tetrahedron has a bond angle of 109.5 degrees. Okay, and this is a polar. Okay, remember everything in group 15 and 16 for your central atom is polar, but group 14, the central atom for carbon, is also polar if the other atoms around the central atom do not match. And in this case, you have chlorine as one of your kinds, and then you have hydrogen as the other kind. So those atoms around don't match, so that's going to be polar. Okay, the next one we have is cesium Cs and chlorine Cl. So we just looked up chlorine. We don't have to look that one up again. But let's find cesium Cs on the periodic table, and it is right here. That's in group number 1. Remember, everything in group 1 has one valence electron. Of course, chlorine we just looked up is in group 17, 7 valence electrons. So let's draw this out. We have cesium with its one valence electron, and chlorine is going to be just like up above there, where it has 7 valence electrons. There's not a central atom here because there's only 2 atoms, okay, cesium and chlorine, so they're going to just line up like this. We have cesium, and then let's change the color here. We've got chlorine. 1, 2, 3, 4, 5, 6, 7. Okay, so we have cesium. That line right there represents a covalent bond, 2 electrons, one shared from cesium, one shared from chlorine, and then chlorine has the remaining electrons, 6 of them that are not being shared. Okay, and this is linear. We have a group 1 element and we have a group 17 element, and those create linear, or a line. Okay, and a line would be 180 degrees, and that would be polar. Okay. The next one we have Pi3. So let's look those up on the periodic table. Pi3. P is phosphorus, and it's found in group number 15. Everything in group 15 has 5 valence electrons. I is iodine. That is group number 17. So that has 7 valence electrons. So we have a group 15 and a group 17. P, phosphorus, group 15, has 1, 2, 3, 4, 5 valence electrons. And iodine, let's draw one of them. There's 3 of them that we're going to be using in this dot structure. Oops. Group 17 is 1, 2, 3, 4, 5, 6, 7. Okay, so remember, which one is going to be at the center? Which one's going to be the central atom? Well, which one has the most single dots again? Phosphorus, the P, has 1, 2, 3 single dots, and the iodine only has 1 single dot. So the one that has the most single dots, P, phosphorus, is going to be at the center. It's going to be our central atom. So we're going to put that right here. Phosphorus, okay, and it has its 1, 2, 3, 4, 5 valence electrons, 5 dots, and then we're going to fill this out with iodine. Okay, the iodine has 1 that's being shared with phosphorus, 2, 3, 4, 5, 6, 7, because it's a group 17. Another iodine right here with one electron that's being shared with phosphorus. 1, 2, 3, 4, 5, 6, 7. And remember there's 3 of them, so we've got one more iodine, which is sharing one electron with phosphorus. 2, 3, 4, 5, 6, and 7. Okay, and you'll notice here that phosphorus has 8 valence electrons. So if you count them out, each iodine has 8 electrons, and that's a stable octet for each one of them, that's what they want. They want stability with 8 valence electrons. So our structural formula for this, we're going to have phosphorus with a valence electron, with a covalent bond with iodine. That covalent bond right here represents 2 electrons. Iodine has one of them. There's 2, 3, 4, 5, 6, and 7. Here's another covalent bond between phosphorus and iodine. And remember, iodine has its remaining electrons. And another covalent bond right here. And then phosphorus has one lone pair right up here. Okay, that's not being shared with a covalent bond. Okay, this shape is trigonal. Pyramidal. Okay, and the bond angle for trigonal pyramidal is 107 degrees. Okay, and remember, all group 15 and group 16, this is a group 15 element, phosphorus in the middle, is polar. Okay, so that's that. You have the rest of these to do. You have a few on the bottom here. Let's take a look at a couple of these questions on the bottom. So the thing that determines the shape of the molecule, we're going to be looking at, we're going to really pay attention to the central atom. We're going to be paying attention to the central atom. It's going to tell us how many, the one that has the most single dots. Remember that electrons repel each other. Okay, electrons repel each other as much as possible. They get as far apart as they possibly can. Electrons repel each other. Okay, and then so what we're looking at are the electron, how many bonding pairs, okay? How many bonding pairs, bonding and lone pairs that the element has, okay? Why is the shape important for molecules? Well, the shape determines the characteristics. So it determines the characteristics of the molecule. So things like melting point and boiling point are the characteristics that are taken into consideration for this. So anyway, those are some examples. You got a few questions left here to do, but good luck on this. Use your periodic table. Get help. If you're not sure what these answers are on these bottom ones, get help from your chemistry teacher. Get help. You can look these up. Look them up on the internet if you want. Use your notes. But we're here to help you out. Good luck on this.